We want to solve the simultaneous equations 3x plus y equals 9 and 4x minus y equals 5. Solving simultaneous equations means we need to find the values of both x and y that satisfy both equations. Writing down our two equations, 3x plus y is equal to 9, and we'll call this equation 1. Then we have 4x minus y is equal to 5, and we'll call this equation 2. Note we have the same number of y's. One is a plus and one is a minus. If I do equation 1 plus equation 2, 3x added to 4x is 7x, plus y add minus y, so we have plus y add minus y, which is equal to y take away y, is 0. So the y's disappear. Then we have 9 plus 5, which is 14. It follows that x must be equal to 2. We now take this value and substitute into either of the original equations. In this case, I'm going to substitute into equation 1. If x is 2, then 3x's is 3 times 2, which is 6. 6 plus y is equal to 9. Taking away 6 from both sides gives us y is equal to 3. So our final solution is x is 2 and y is 3. When dealing with simultaneous equations, we should always check. If it works in both equations, then we know we have the right answer. Looking at equation 1, with x2, 3x is 3 times 2, which is 6, plus y, which is 3, so we have 6 plus 3, which is equal to 9, and this is right. 4 2's are 8, take away 3, so we have 8 take away 3, which is 5, and this is also correct. So we know the solution is x equals 2 and y equals 3, and by checking we know that this is definitely right. As a second example, consider 2x plus 2y is 14 and 3x plus 2y is 18. Writing these down, 2x plus 2y is equal to 14, call this equation 1, and 3x plus 2y is equal to 18, and call this equation 2. We have the same number of y's, and they have the same sign, they're both pluses. If we do equation 2, take away equation 1, and I've chosen to do it this way round, as I have more x's in number 2 than I have in number 1. We get 3x minus 2x is x, plus 2y take away 2y is 0, so we have no y's. We then have 18 take away 14, which is 4, so x is 4. Now to find y, we can substitute in either of the original equations. Here I'm going to use equation 1. If x is 4, 2 4s are 8. So we have 8 plus 2y is equal to 14. Taking away 8 from both sides gives 2y is equal to 6. And dividing by 2 gives y equal to 3. So our final answer is that x is equal to 4 and y is equal to 3. Once again, we should always check the solution. Looking at 1, 2 4s are 8 and 2 3s are 6. 8 plus 6 is equal to 14, and this checks out. Substituting into 2, 3 4s are 12, 2 3s are 6, so we have 12 plus 6, which is 18, and this also checks out. So x equals 4, y equals 3 is the correct solution. Let's compare part A and part B. In part A we had the same number of y's, but the signs were different. If the signs are different, for the letter we have the same number of, then we add the two equations. Different, add. In part B we had the same number of y's, but the signs were the same. They were both pluses. If the signs are the same, on the letter we have the same number of, we subtract the two equations. So we need to remember different add, same subtract. So let's now consider this example. 2x plus 2y is equal to 9. Call this 1. 2x plus 3y is equal to 3. Call this equation 2. We have the same number of x's. And note, if we just write 2x, what we mean is plus 2x. We just don't write the plus. Therefore, the signs are the same. If the signs are the same, then we know we're going to subtract the two equations. So let's do equation 2, take away equation 1, choosing to do it this way round, since we have more y's in equation 2 than we have in equation 1. So we know 2x take away 2x is 0. The x's disappear. 3y take away 2y is just 1y. 3 take away 9 is minus 6. So y is minus 6. We can now substitute into either of the original equations. I'm going to choose to use number 1. If y is minus 6, 2y's are minus 12. So we have 2x take away 12 is equal to 9. Adding 12 to both sides gives 2x is equal to 21, and therefore x is equal to 10.5. So our final solution is x is equal to 10.5 and y is equal to minus 6. As always, we need to check our solution. Let's look at equation 1 with x equal to 10.5 and y equal to minus 6. 2 times 10.5 is 21. 2 times minus 6 is minus 12, and this equals 9, which is correct. We also need to check equation 2. 2 times 10.5 is 21. Plus 3 times minus 6, so that's minus 18. 21 take 18 is 3, and this is also correct. Here we have 2x plus 4y is equal to 14. Call this equation 1, and 2x minus 3y is equal to 7. Call it equation 2. We can see that we have the same number of x's, and the signs on these x's are the same. The same sign means we subtract. If we do equation 1, take away equation 2, 2x take away 2x is 0, so the x's will disappear. We then have 4y minus 3y. 4y take away minus 3y becomes 4y plus 3y. So we have 7y. Remember, what we've done here is equation 1 take away equation 2. On the right hand side we get 14 take away 7, and therefore y is equal to 1. Substituting into one of the original equations, in this case I'm going to use number 1. If y is 1, I get 2x. 4 ones are 4, so we get plus 4, is equal to 14. Taking 4 from both sides here leaves 2x on the left and 10 on the right, and therefore x is equal to 5. So our final solution is x is 5 and y equals 1, which of course we need to check. Checking in equation 1, 2 5s are 10, plus 4 1s, which is 4, gives us 14, which is correct. Checking in equation 2, 2 5s are 10, take away 3 times 1, so take away 3, is equal to 7, which is correct.